Okay, good evening, everybody. How are you? So, how many of you downloaded last 2 week lecture program? How many of you got? How many of you downloaded the program I demoed last week? That is on my GitHub account. Did you get it? In your lab, you will be asked to develop your own linked list. In your lab and assignment, in the upcoming lab and assignment, you have to develop your own linked list along with the method for prepend, append, searching, deleting, and display like this. So anybody has any question about linked list implementation? How many of you actually did practice? 1, 2, 3, 4. Okay, pretty good number. So people who practice actually, have you any question? Have you any problem? Okay.
Are we going to Doubly?
Okay, yeah. We'll do WLC. So in the test, so in the upcoming test, you will have we will have linked list, then stack, QE. Okay. So what do you like? Do you like me to recommend for program code or like the pseudocode or steps like this? So for instance, this is the insert method. Insert method is two kinds, as I discussed, right? Prepend and append. Append means adding at the end, okay, and prepend means adding at the front, okay. So now these are the steps. Actually, this original slides were like this way. It described how to append, insert, how to delete, okay. So in your test, maybe you will be asked to write pseudocode for insertion and deletion, something, okay. So now I don't have enough time to go through. So, but do you like me to go through all of these slides, or you will read these slides? Yeah. As a linked list, we are creating as an object because we are creating a class node class, right? Within the linked list class, we are creating object of the node, right? So everything is an object. And also within the main method, recall that we used we created within the main method, we created an object of the linked list class. So we explained this one, single linked list. So people who are in the back, can you see my code, or I need to expand the font? Okay, so this is a class. So when we create an object of this class, this definitely an when we create an instance of a class, then definitely that is an object. So what was your question? I'm not sure.
Yeah, so in a linked list object array of integers, if you were to have that filled up just randomly, you try to delete the instance of one in that list. Would it delete every instance? That integer?
Okay, we have a delete method over here. I could not go through in the last class. So delete method is over here already. So delete method remove is same thing. Remove method and delete method is same thing. Is remove by ID. You can remove by ID and or you can remove by name. You can remove by name. Any element you can remove by. So these are all not straightforward. Is really you need to sit with cool brain and you need to do some practice. Okay. I wish I would have 2 weeks at least for discussing linked list. Then I could go through all of this method. Okay, but now question maybe I will answer your question. Already in Java there is a built-in in Java utility class there is a built-in linked list. We can use this. Okay, so for instance I have a program over here. So using built-in linked list. So in Java utility class, so you will see there is an already a class. It is called linked list. Okay. So and you can create an instance, that means an object of this class, and you can use, there are some method like add method. Okay, add method and then add first, add last. Add last means append, and add first means prepend. Okay, and there are also remove first and remove last. These are already methods. So okay, so there are two kinds of method in remove. It is by ID or by pair. So this one is remove. Let us go through this method. So it says it's open implementation. If we go through open implementation, so is the implementation here? I think the implementation is not added here, but if you go through the implementation, you will see you can remove by ID, by the index. This two means the third element. These two means remove two means you are going to remove the third element of this linked list. You are going to add 0 means you are adding at the index 0. That is the first element. Yeah.
So does remove first and remove last, you don't need to explicitly write them themselves, they're
No. I'm asking that if you use the built-in linked list class, there is a built-in linked list class, okay, in Java utility package. If you use Java that linked list class from the Java utility package, then you will be able to use that add method, add first, add last, remove first, remove last, add any with an index. That means I'm telling that there is already a linked list built in already in Java. Maybe same thing in C#. Okay. Then the question is that why do we need to learn this? Is this your question? Why do we need to learn this? We need to learn actually when you will take advanced level class, a data structure, or if you do software engineering and software development task, then you need to know this, right? Yes.
So our lab was array list and linked list.
Okay, then another question is that there is also array list. There is also an array list, built-in array list, that is dynamic array. Dynamic array that at any point you can add any at any position you can add any element. So I saw that in your lab it asks you to use both array list and linked list.
Okay, so my question is, when should you use which? Or like what
that is the question. When you use array, okay, array contains same element, okay, same type of element, and mostly when you know ahead of time what will be your element size, how many elements you will have, then you use array, right? But when you are uncertain that how many elements you will have, you don't know ahead of time, then we use linked list. Array is a data structure, linked list is another data structure. So the array list Java has, that is dynamic array list. And the array so far you know in your 1321 class, that is called static array. For static array you cannot change your size and runtime. But dynamic array, this array list, you can add any number of elements. Okay, so array list and linked list has a node. Every node knows what will be the element next to it. Okay, so let me go through something else in depth from our previous program. So we discussed this one, right? So so here we have added some, we have append and prepended some elements, right? Some nodes. So for instance, if I say before display elements, I'm here. So sys out. Sorry. So in array list, if we say node dot next, okay, then you will go to the next node, right? Okay, and if you say node dot next, then you will go to the third node, right? I want to say this on sys out. Okay, just I gave a barrier. Okay, so that here I am. I want to show that here I am. Okay, so anybody please help me. If I say linked list dot next. Okay, so if I say linked list dot display display all nodes. Okay, display all nodes. Okay, if I already have display all nodes, right? So let me see. Everybody please give attention. If I say linked list dot, okay, dot instead of dot link display all nodes. If I say linked list dot next, is it showing next? No, not here. I'm sorry, not here. I want to show you here. I have my, okay, I have here. Okay, yeah, please just give attention. If I say n1, in our last class we saw that if I say n1 dot display node, then what it will show? It will show the node n1, right? It will show the node n1, right? And if I say n1 dot next dot display, you see this one. If I say this one n1 dot next dot display, that it will show the data node of the next node. Like for instance, like this, if I have a node, this one my n1 node, and this one my n2 node, and this one my n3 node, this is my n3 node, and this is my n2 node, and this one my n1 node. And for instance here, if I say n1 dot next dot display node, so then it will show me, it will display the data of the second node. Okay, and then if I say n1 dot next, then it will go, n1 is here, right, and the left one is n1, then n1 dot next means n2, and n2 dot next means n3. So this is the sequence. So for your question, you asked me what is the difference between array list and linked list, right? An array does not contain the array does not know who is next to it. An array element does not know who is next to it. What is the element next to this element? Every element in an array is distinct, independent. It does not know, okay, its neighboring element. But in a linked list, every element knows, okay, who is next to it. Okay, so the advantage of array list is here, so you can have like fixed time, okay, constant time to pick any element from the array. But in the linked list, okay, if you want to find element of third node, then you have to start from the head. Where is the head? Always head will be the first node, right? Then you have to start from first node, then go to the next node, and then go to the next node. So both array and linked list have advantages and disadvantages over each other. Okay, but still I'm telling that we already have linked list implemented in Java, okay, and C# as well as most of the modern programming languages. But still we need to learn this implementation in order to prepare you for taking other advanced level classes in when you will take next level classes like data structure and algorithm. You have to develop your own data structure. Understand? Okay. So if you go, if you go to my Github project, that I have already a program. It is called linked, using built-in linked list, and also it has using built-in array list. I have another program here, built-in array list, and okay, another difference is that an array can contain only one kind of element, but we saw that a node can contain multiple types of elements, right? A node can contain ID, name, GPA, grade, right? As many data as you need. But an array can contain only a unique single type. If you have an array of string type, then you can add only string. Okay? If you have an array of integer type, then you can only add integer type. This is another limitation of array. Okay, so and people here, you see here, when using array or linked list, we use something, this one. It's called generics. Is it here? You see, when array list, so here generic means, okay, in a book you can search more, but generic means, still I don't understand. I'm not comfortable with the name generics. Okay, to me it seems to be restricted. Okay, but the people say that it is generic. Generic means that, for instance, if for this program I can do this way. I can run this program, it will same thing. It will do same thing. Here in CC array list AL equal to new array list, I can say A or AL dot add. That means this element will be first element, item 1 will be first, and item 5 will be second, and item 3 will be third. Okay, but here there is a limitation on this line. Please give attention on line number 8. There is a limitation here. The limitation is that, so when you declare an array list AL object, array list object AL, okay, like this way, everybody understand this, right? This is a class, right? Class, this is object name equal to new class name, right? So it means you can add, for instance, you can add AL dot add, for instance, 1255, a number. Okay, it is not giving you any error message. Okay, for instance here, or you can add AL dot add true. You see, any kind of data you can, okay, sorry, not add all. Add all means add true, right? But there is a restriction over here. There is a limitation over here. So if you are intended, okay, to add only, like for instance, only string type of elements, but by mistake if you add any integer type or boolean type element, right? For instance, but while going to do operation on this element, for instance, on string type element, you can find string length, right? For a string type object, you can find string length, right? Or you can do string reverse, right? But for an integer, you cannot do a string length, right? For a true or boolean value, you cannot use a string length method.
You start to roll around the
Oh. Thank you. You see, the limitation is that, for instance, if you do mistake in inserting data in an array list, okay, in a way that you insert a data that is not your expected type, then you will not get any error during your compile time, but you will get error during runtime. Okay, in order to protect that kind of runtime error, okay, so that programs, like for instance Java and C# programs, they have another restriction. It is called generics. Generics means when we are going to declare an array list or a linked list, we assign the type, element type within angle bracket. So that means you are restricting that your array list will take only in string type, okay, and then it will not take any other type except string type, and this is called generic. Okay, so if I have generic, then I cannot do this. You see that I cannot do this. See the error here in these two lines? Guess that why it is error coming here in this line? Because I have restricted that this AL will take only string type. Okay, but I am adding an integer type. Okay, so this is giving me an error message compile time. If you get an error message at compile time, it is easy to fix your bug. But if you get an error at runtime, then it is really difficult and time consuming, and it is difficult, okay, to maintain that, because you don't know what is your error until the program runs. So this is called generics. Okay, generics means restricted. So I understand this way, restricted, but people say that it is generics. Yes, now I can answer your question. Yeah, anything, linked list as well. Yes. I told you in the linked list you can add how many elements we added. We added integer type ID and we added name, string type, right? I can add any other more types, more fields. In array list, you can use only one kind of, either integer type or string. No, not double type, two types here. Here is mixed type, right? This one? Using built-in linked list, this one? This is, okay, this is not array list, okay? In array list and linked list, there are some methods common, like add. Some methods are common name, but this add, do not confuse about this add method. This add method is, what is that? So if I hover my mouse over here, this add method is a linked list type. It is defined within linked list class. But this add method is a array list type. Linked list? Here? Here? This is not this declaration, this is restriction. I am restricting that this array list will contain only string type data. Yes. The package linked list means that I described in last class. Yes, this is built-in. This is the built-in one, okay? But I described how to develop like this kind of built-in linked list. In our last class, I described. Now, maybe some of you are confusing, since there is a linked list already built in my Java, right? Why do I need to know how to develop a linked list, right? Was this your question? No, I think no. No. This is called generics. Okay, it is called restriction. So if I say integer, I say integer, integer. If I say integer over here, then that means I am restricting that this linked list object will add only integer type. But what type I give here? String type, right? Here, look at the value. String type, right? I put a string, right, within double quote, right? So that means it is showing me an error at compile time. Oh no, sorry. So if you missed last Thursday, then you will not understand. Please watch my video. I uploaded the entire last class video. Okay, and watch that. And until you understand last class video, you will not be able to understand today's class. Okay, and what is your question? You have a question?
I got an answer. Thanks.
You got an answer? Okay, so this integer means, okay, you are binding that this linked list will contain only integer type. Okay, so that means you cannot add any other type data other than integer. And if you want to do that by force, then you will get a compile time error. Okay, so which one is cheaper in terms of bug fix? Runtime error or compile time error? Yes, compile time. Getting a compile time error is better, okay? Because if you get a compile time error, you can fix it ahead of time. But if you have some runtime error, until your program is running and until your program goes to that certain situation, you cannot know that bug. Okay, so bug fix is difficult and more costly and more dangerous for runtime bugs. Okay, so in order to restrict runtime bugs, so this is called the is most of the linked list and array list are restricted with this generics. It is called generics, but I understand it's not generic, it's restricted. I remember this way. Okay, in your book you will see generics in collections. So in linked list, array list, tag, QE, these are in general called collections. In your book, maybe in some book, you will see a chapter, it's called collection. Yes.
So like, you know how when we did, when we made our own linked list last class, so we gave it a string type and an integer type data field?
Yes.
So like, how would you do that using the built-in linked list? Like, since you've restricted it to string, would you just take the restriction out and it would just be, like, how would you allow for, like, an integer and a string to be?
Yeah, you can add more, another string, another integer here.
Just add it?
Integer.
Okay.
Oh, you have to put integer in wrapper class. integer. This first element will be integer, and then second will be string, and then here first element will be integer, then second element will be string, and then you have to add integer, first one integer and second one string, like this way. That is possible. Okay. Sorry. Okay. So far we discussed, this is called singly linked list. Singly linked list we discussed in last class, but there is another linked list that is called doubly linked list. Doubly linked list means every node knows who is next to it, and who is front to it. Okay, so doubly linked list, so we will discuss here. I have added another program, it is called doubly linked list. Okay, so doubly linked list is same thing like a single linked list, but it has, okay, so since I have this within same package, so I rename the node as D node. Okay, everything is same almost. D node means doubly linked list node, otherwise do not confuse. Okay, so I have ID and name over here, but one thing I have additional, that a doubly linked list contains and knows the element who is next to it. For instance, a single linked list, it knows who is the head. Okay, it knows who is the next, and then it knows who is the next. That's it. And this last one will be null. Okay, null means there is no one is at the end. Okay, and there is another kind of linked list that is called doubly linked list. A doubly linked list node knows who is next and who is front. For instance, this node also knows who is next, and it also knows who is at the front. And this also knows, okay, so null is here, this is the top one, and it also knows, this also knows who is front. So this is the concept of doubly linked list. You understand? Do you have a question, any? So a doubly linked list has one more extra node that is called previous. I said previous or PREV. Previous means this node will know who is the previous node. Okay, since it has an extra node and its implementation is a little bit complicated than singly linked list implementation. Okay, so in your lab class you will be asked to develop a linked list. Okay, either a singly linked list or a doubly linked list or a stack, maybe. I'm not sure. Okay, so I like you to go through my previous program and understand the singly linked list. The singly linked list program, understand this one clearly. Okay, so once you understand the implementation of this singly linked list, then go to the next program, implementation of doubly linked list. These are already almost same, but I have made a little bit different in the doubly linked list. For instance, in my singly linked list program, I stated that how do I know that my node is null? Okay, if head is null, right? There is no null, right? There is no data, right? There is no node means if head is null, right? And here there is I told that on that time there is another alternative way to figure out whether a linked list is an empty or not. There is another, the alternative way is to find the size. If your size is 0, that means there is no element, right? So this is an alternative way. So this is a way I said initially when we call this constructor, we initialize this size element as 0. That means initially in the initial node we will have size 0, and then if we get return 0, size equal to 0, then we understand that this linked list is an empty linked list. It's a little bit different implementation for this size or empty linked list implementation. Here we said if head is empty. What is that? Is empty function. You see that is empty. If head equal to null, that means we said empty. And other than in doubly linked list, we said if size equal to 0, then that is empty. Yes.
So I'm not understanding, in your doubly linked list, in your constructor, you have this size equals 0. What's the purpose of that? I don't understand.
Okay. So initially when a linked list is an empty, right?
Right.
Okay. Then what is the next step you need to do?
Put it in.
No, create a node. Right? For instance, here let us go to our main method. So DLL doubly linked list. Okay, so I have created an object. So it's DLL, right? So what is the DLL size? If I say sys out, okay, if I say DLL dot size, what do you expect? Is this size or is empty? Maybe there is no. Maybe the method is here. There is no size method. Sorry. Is the size method. The size method. Okay. So here, if say DLL dot size, what do you expect?
0.
Okay, let us see if I have 0. Yes, I will have 0. This is 0, right? So initially when you just create a linked list object, right? So you are imagining that you have an object, but there is no node linked with it.
It's like still a link.
No, empty link, imaginary link. For instance, so for instance, you do not have any book.
Right.
How many books do you have?
Many books.
You do not have any book. So how many books you have?
0.
Yes, same thing.
Okay.
Okay, but in your imagination, you have a book. You know a book, right?
I know of a book, but I don't have a book.
Yes, that is size is 0.
Okay.
Count is 0, right?
Okay.
Okay, so that I told you that there are 2 ways to implement the size. One is using a size variable with initialize as 0 here. You see here 0 integer size variable, but you can initialize that as 0 when calling your constructor. Otherwise, in our previous program, I showed that alternatively I can use head equal to null. Null means, oh no, not null means empty.
Right. That's what I mean.
Same thing. Just different implementation.
Okay.
Okay. Okay, so I want you to go through the singly linked list program first, step by step, and then go through the doubly linked list program. If you do not practice singly linked list, you will not understand the doubly linked list program. Agree? So if you understand linked list, then this is your gateway to do good or well in your next class, data structure class, and algorithm class. There is no way then you can skip it. Okay, so let me see how many. Okay, so now I think if you go through program first, and then now these are the algorithm actually. How the delete method works, how the insertion method works, okay? And in my last class, I explained almost everything, how the insertion, actually insertion has two kinds. What are those? Can anyone tell me what are the insertion type?
Append and prepend.
Yes, append and prepend. Prepend add on the front and append add in the back. Okay, same thing for singly linked list and same thing for doubly linked list. Okay, so these slides do not have complete program. Okay, these slides just read for the piece. These slides have every individual pieces of the element of a program, but my program has complete program. You cannot run this code. This is just code snippet. I think now go through the program and try to understand this algorithm like pseudocode. So anybody has any question about singly linked list? Okay, not you, because you are not in last class. If you were not in last class, I will not answer your question, okay, for today. It's way difficult for me. No, sorry, I did not know that I'm asking, I did not know that you are not in last class. Okay, I'm sorry. Okay, so now we will the next slide is for doubly linked list. Doubly linked list, as I discussed, it is same, but the one thing is different, that every node in a doubly linked list knows who is next to it and who is previous of it. That's it. So it has only another one more extra node for previous, and this is why, since it has one extra node, so its implementation is a little bit complex than singly linked list implementation. But if you understand singly linked list implementation, then I believe you will be able to understand doubly linked list. Paris, do you have any question?
I do.
Okay. What is your question, please?
So I'm still learning what blockchain is, so people know use for the simple question. But I've heard that blockchain is pretty much an advanced video. Is that true?
What is that on?
Blockchain, is blockchain pretty much an advanced version of a linked list? Is that true?
What is that called?
Blockchain, like,
Blockchain. I have a blockchain.
Yeah.
The linked list is a kind of blockchain, like the necklace. You wear necklace, right? Anybody has here a necklace? What is a necklace? Linked list is a kind of necklace. It's
No,
a
it's a like transaction of like currency.
okay.
like blockchain in relation to Bitcoin and data mining and stuff like that. It's like
Oh.
multiple systems are connected to one another on one node.
So yeah, in order to implement that kind of system, you need to use linked list. So like for linked list and this kind of data structure is needed in order to implement sophisticated data. Sophisticated, like for instance, we use a social network, right? Facebook, right? Okay. So right, for instance, I have my own friend list, right? And you have your own friend list, right? If I am connected to you as a friend, then I will be able to see who are in your friend list, right? If I am a node and you are a node, and if we are connected as a linked list, then I will be able to see who are in your friend list. This is a kind of linked list implementation. Actually, in order to develop a program, a complete application, there are many data types, data structures are used combinedly. There is no single thing that you will use in your entire program. But still you do not know what you will use when. You have to learn everything, almost. The basic thing, right? Actually, these are the foundation. Actually, this class is the foundation of your programming language class. I was grading you in your test 2. Many people, they said abstract or class interface. Is a class an interface? You said they declare class interface. For instance, this class, they say name, they say public, they say public class interface. For instance, XYZ. Is this valid? Why a class can be an interface? So class is not an interface. Interface is interface. Either interface or abstract class. Right? Okay, in DoublyLinkedList, there are 3 kinds of insertion. Okay. This is at the beginning, at the middle, and at the end. Okay, in single linked list, we have 2 kinds of insertion, right? Prepend and append. And here it has prepend and append. End means append, beginning means prepend, and it has also midpend or something. It's called middle. So when you get time, so please go through. You see the algorithm for insertion in the middle. So for instance, if you want to add an extra node here, for instance, I have this node and I have this node. So this node, this guy knows who is next to it, and this second node, it knows who is before it, right? Now if I want to add another node in the middle of these two, this is my node 1, this is my node 3, and if I want to add my node 2 over here, then what do I need to do? I need to delete this, right? I need to, is this eraser? I need to delete this, and I need to move this, sorry, I need to move this one to here, and actually I need to do this way. I need to move first here, this one to here, and this one to here, and then this node to here, as well as this node to here, and I need to delete this one. So it's a little bit complicated. Okay, insertion in the middle in the doubly linked list, then inserting into doubly linked list in the middle it shows. Okay, and deleting something. Delete an element, delete from the beginning, delete from the end, and delete from the middle. As we delete a node from the middle, you have to reassign your previous and next node's connection, right? So, but this will take some time. So, please go through the program that I put on my GitHub account and run, and is a single page. Like, understand the insertion method first, then understand display, like for then understand delete, then understand search or find. Go this way. Actually, these operations are really difficult. You need to spend some time, extra time, and you need to study with cool brain. I think your lab in the upcoming labs and assignment have something. Try to understand this program and then build your own linked list. Anyone has any question? Okay, definitely if you start programming, then you will have question. Okay, start programming, and then if you question, please come to my office, and then or send me message on. I can see your program if you put on GitHub in your GitHub account, and if you add me as a collaborator, then I can get your program and I can help you. I have 10 more minutes. Okay, so let me start tonight, and then my next class I have to complete another topic that is called stack and queue. I think you is there anyone here can understand stack and queue? What is a stack and what is a queue? Maybe I discuss sometime. A stack and a QE, stacks and QEs are other kinds of data structure. Okay, a stack means a pile. For instance, if you have a stack of plates at home, you wash your plates and then you put on a stack, right? Yes.
Yeah, so stacks is lead flow, last one in, first one out, and queues, it's the other way around, first one in, first one out, right?
Yes.
Yeah.
Yes. A stack is called a LIFO type data structure. LIFO means last in, first out. When you put a number of plates, okay, when you wash plates at home, for instance, and then you stack your plates, for instance, you wash the plate first, and you put that one on your table, and you wash next another plate, and you put top of that one, and you wash another plate, and you put top of that, regular way, okay, unless you do something else, okay. But when you use the plates, okay, which one you get first? The last one, right? The topmost one, right? Topmost one was the last one, okay. That is called a stack. Last in, first out. That element that came last in the data structure but goes first, okay. It's one side, this side is, because in the stack this side is closed, the bottom side is closed, okay. So you have to in and out from the top, okay. The in means insertion. The insertion operation in a stack, it is called a push, okay. And the extraction operation of a stack, it is called pop, okay. And pick, it returns the top element, okay. But the difference between push, okay, the pop and pick is that if you do pop, okay, then one element will be deleted or removed. But if you do pick, the element still will stay there, but user will just get the value or get a copy. Okay, pick means you get a copy, and pop means you are taking it out, and push means you are inserting, okay. So if you understand linked list, then understanding stack is easy. Stack implementation is easy, will be easy, okay. And QE, okay, so in Java and then C#, you will see, so you can implement a stack by using array list or linked list. Almost similar kind of implementation, okay. You can use it. But in order to implement a stack, you just need to only few operations: push, pop, and pick. And there is also some other methods. It's called isEmpty. isEmpty, whether it finds is empty or not. You see, if you understand my linked list program, then this program understanding and implementation, this program is easy. Let me see. I will go through in next class the entire program, okay. So for this implementation. And QE is another data structure that is called first in, first out behavior. That has first in, first out. So when you go to a train station or bus station, when we wait for a bus, what do? We stay on a line, right? The person who comes first, he gets first, or he goes first, right? That is called QE. Okay. QE has enter in one way, okay, and exit in another way. But stack has enter and output in the same one way, because for stack the one side is closed. Okay, so but QE is called first in first out. The elements, it comes first, it goes first. For instance, students who are admitting here ahead of you, like for 4 years of you, okay, in generally they are graduating ahead of you, right? And the students who will come next to you, otherwise, if someone is not exceptional, then student who will come, who will take admission later, they will graduate later. Okay, so that kind of operation is called QE. Okay, and unlike stack, and then QE has only a few operations, add operation or remove operation. In QA, add operation is called NQE, and deleting operation is called DQE. NQ and DQ operation, these are well-known operation for stack for QE. Okay, so QE can be implemented using array list or linked list. So definitely the linked list is the foundation for understanding array list and linked list. So you see the program is simple, not too many too large like linked list. So if you go through my GitHub project, then I have added a what is that called? Package. It is called stack and QE, stack QE. So you see in this program it has stack implementation. It has stack implementation program. This program is not too large. Okay, this is simple than your linked list program. Okay, so everybody, when you go home, please download. Okay, please clone this project and try to understand linked list first. And in my next class, I will explain. Okay, then stack and QE. But meanwhile, okay, so please practice single linked list program first, and then go to doubly linked list. Okay. Then come here, and then we will go through stack and QE in our next class. If you understand linked list clearly, then this will be easy for you. And also another good thing is that in Java utility class, and then who are taking C# class? Okay, the C# also has stack and QE. Okay, so in Java utility package, stack is a built-in class. So that class, it has push operation and it has pop operation. But if you want to implement your own push and pop operation, then you can do it. But I like you first to go through single linked list, then doubly linked list, then stack and QE. Okay, so how many of you do not know yet how to clone a GitHub project? Is there anybody here? Okay, so everybody, I like everybody to be used to in using GitHub. Okay, so if you go to my GitHub account, then you will see I have this. What is this program? Okay, github.com/CSE1322, and then go here and you see that I have repositories, 29 repositories. Among these, you see CSE1322 review, right? This one is program. So go to this repository and click here, and then click here, get the address and clone it. in your project, then import it. And if you still do not know how to clone a program, there are a lot of tons of video and the online resources how to use GitHub. If you use GitHub, then your life will be easy. And then all companies and all industries, they use Git version control system. No company uses flash drive to copy a project. Okay, so if you start using GitHub, like within next 3 or 4 years, you will have a like good repository, right? Then when you go for an interview, you can show that I have this number of GitHub project. And people at a glance, you will say, oh, he's a good programmer. Okay. Okay, anybody has any question? Okay, thank you so much. And everybody has a good night.